Okay, we're live. I guess, first of all, thank you everyone for joining us on your Saturday. Appreciate you spending some time with us. We've got Summer Rankin over here, PhD and course author for the upcoming ADS 101 Python for Data Science course, instructor for GTK Cyber, and also over at Booz Allen Hamilton as a senior lead data scientist. So quite a long list of titles over there. So welcome everyone. Thank you, Summer, for joining us. I think you've introduced yourself in the past podcast, but feel free to again, just for the listeners here, and then we can just jump into it.
Sure. Yeah, hey everybody, I'm Summer. I'm my main capacity here for Level Effect is the as a course designer and an instructor. We do a lot of different online courses as well as some Black Hat offerings. We teach every year at Black Hat USA, and I actually just got done doing Black Hat Asia a few weeks back over at Singapore. That was cool. But yeah, I'm a data scientist at Booz Allen. That's like my daytime job, and then this is kind of my like side hustle.
Cool. Thanks for that. How was Asia, anyways?
You know what?
Yeah.
I immediately it was rough because I like landed, I went to sleep, I woke up and I was so sick the whole time. And so I was just like masked up and like on so much cold medicine. It was crazy. So unfortunately, it I did not get to do much exploring. Um, I hope I was able to deliver somewhat of a decent course to everyone, but hopefully I will have a little bit more fun the next time I go. It was in Singapore, so getting to see like even just the hotel where it was that oh gosh, that one where the sides of the building are like curved, and I got to see the of course the airport with like that giant fountain in the middle. So that those things I did get to see, and that was fun.
It's pretty cool. Nice. Yeah. Seems like everyone always kind of gets like a little bit of travel sick whenever they go to these events.
Oh
Just
man.
yeah, it's always the worst timing, but at least I'm glad you enjoyed over there. Did you teach the applied data science course at all, or anything along those
Yeah,
lines?
that's
Yeah.
what I yeah,
Nice.
that's what I went there to do.
Cool. Very cool.
It's
Well,
usually Charles that teaches it, but
yeah.
he had some like last minute stuff come up, so I covered it.
Awesome. Very good. And you're going to be doing it again sometime soon, or is Charles doing the
Yes,
next one over
so
here in Vegas?
well, so we have in Vegas we have two sessions of it. So the first session, I usually do that one, and then Charles does the second session because it's a 2 day course. So there's 4 days of training that happen before Black Hat. So the first 2 days of the training is like our, cohort number one. And so I usually do that one, and then the second, so that's like Saturday, Sunday. Then the Monday, Tuesday class, Charles does it, and then I just like help. I kind of hang out.
Cool. Very cool. Did you? And I'll stop hogging over here. I'll hand it off to some of the audience over here. So get those questions in chat. I'm just kind of curious. Did you teach any of the Python content that you're packing for this content right now, releasing on June 7th, or did you just jump right into
No,
ADS?
yeah. So ADS is packed. Like it that course, I never get through all of the content. So I definitely don't have time to go over any Python in that course. Which it's kind of an interesting problem sometimes because people want to take the course, but sometimes it's actually kind of what made us want to develop the Python course because they really do have to come in like knowing a good amount of Python because we just jump straight into like here's how we do data engineering, and then we get into straight into modeling like at the end of day one. So unfortunately, no, none of the Python gets taught there.
Yeah. Well, good thing we've got the course coming out to maybe alleviate some of that pressure for those future events.
Yeah, and it's just like it's a nice thing for people to have if they are unfamiliar. It's like we wanted to like hopefully use it as a way to give people a like, hey, this is a prerequisite. Take a look at it. If you don't qualify, then do a little bit of work before you get there, or you'll be lost.
Yeah, definitely. Cool. Well, I guess we can just maybe hop over to some of the questions. I think James over here, you've got several questions over there, so I think I'll try to unpack some of that for you. Um, so you're saying different deep learning algorithms have different specialties and use cases. Is it ever done that several algorithms are combined together and fed into a final algorithm to create a more robust overall system? What's your take on that, Silver?
Absolutely. In fact, it has a name. It is called ensemble modeling. And we do it all the time. So there's actually something called tree-based models. And those are really, it's really common to kind of stack those together, just because sometimes one of them uh, gets you to a certain level of performance, but it's not enough. And so you do a couple of different, tree-based algorithms. And one of the more common ones that kind of does this by design is called XGBoost. And you have a couple of different ways. In fact, a lot of times what happens with tree algorithms is they learn it too well. And so you actually have to like build in a little bit of noise into the algorithm so that it will generalize a little bit better. Now,
Hmm.
deep learning specifically, I don't know that I would stack it in the same way that I would stack like a tree-based or a cart algorithm, but you can certainly use multiple ones together, and it's really common. So, for example, I'm doing something at work right now where the algorithm we're trying to classify, and it's failing really spectacularly at like two out of let's say 20 classes. Um, and so what we do then is we say, okay, let's find the whether or not these items, the things coming in, let's say they're logs, let's find out whether the logs fall into these like three categories that the model kind of sucks at, and make a separate model for those categories. And then everything else that it's doing well at just gets kind of funneled to that algorithm. So it's really common that we kind of stack and stick things together
Hmm.
in a way that allows us to use the best algorithm for the problem, if that makes any sense.
Interesting. There's a follow question there, but something you said there I think might be interesting to clarify. So you said you inject some noise. Like, how do you determine what noise to inject, and how do you I guess how do you ensure that that's not interrupting or compromising the data or the integrity in any degree? Like, how does that happen? That's an interesting thing that you said.
Yeah, no, really good question. So it depends on the model. So for something like XGBoost, which XG, it just stands for Extreme Gradient Boosted Trees. So it's another just kind of a tree-based algorithm, which those are like always my favorite because they're super duper interpretable, meaning you can have like a trace of exactly how the model made the decision. And like in things like cybersecurity, this is usually super duper important because nobody wants like a magical black box that just decided something was fraud or whatever.
Mm-hmm.
They want to be able to say like okay, it's because of the timing of this person, or whatever feature is anyway. So with XGBoost, there's actually parameters, and with deep learning especially, there are parameters or hyperparameters is what we call them, that you can set. And this is kind of where you need to actually have some, the like you end up separating the wheat from the chaff with data scientists, if you will, because anybody can throw data into an algorithm. They've made things really easy, which is good. But if you don't understand how to tune the algorithm, in that like you're tuning these hyperparameters, sometimes you get stuck because you're what's called overfitting to that training data, and you need to add some noise. Well, with deep learning, we have something called dropout. And with like gradient boosted trees, there are a couple parameters that you can tweak. And all you're doing really is just saying like, set dropout equal to, zero point 0.7 or whatever, when you call the algorithm. So you can build it in that way. That's number one. And number two is you can literally add noise to the data. So this is really common with computer vision. So we
Mm-hmm.
have a lot of little images, and you pre-process this data by like making them all the same size and doing all of these things to kind of make them uniform. and then you take them from, pixels to integers, right? It's just like a big long series of integers that you always are putting into a neural net. But what you end up doing too is adding noise to that data and adding that as like a version. So let's say I have a picture of a cat.
Mhm.
I'm going to put in a picture of a cat, but then I'm going to put in the same picture and I'm going to flip it. I'm going to add a bunch of white noise to it, literally, like it's going to be fuzzy looking. I'm going to stretch it. I'm going to turn it on its side. And that's because the model, especially with vision, it learns like all these sort of noisier ways. It doesn't just know, oh, this is a cat in this orientation. It knows that this is a cat in lots of different settings, if you will.
Hmm. That is really cool. I didn't know that that's how that's actually done to train them to that degree. So I could see bias creeping inside there, depending on how you do it, or
Mhm.
maybe level of knowledge, right? Like you can
Yep.
get a very different type of model coming out. Very, very cool. Hmm.
Yeah, and so you monitor these things the same way you'd monitor your model just to test if the model sucks or not, right? So
Yeah.
you're going to monitor, there are all these metrics you can use. But for example, I'll just say accuracy because like that's one everyone's familiar with. Although in real life, you probably don't want to use that because it doesn't measure what you're missing. It only measures what you're getting. But with a supervised model, you're just always going to be measuring like you have this, you train it on a certain section of data and then you test it on a certain section of data it's never seen before.
Hmm.
And that's always what you're measuring is like, okay, how good is my model at stuff it's never seen? And so when that starts to suck, right? When the score on the test data
Hmm.
is not good, you have to kind of figure out why that is. And that's when you walk back that noise, or you need a different kind, or maybe it has nothing to do with that. And you just simply don't have enough samples in your training data for it to actually learn anything. So there's like, a whole can of worms of why, but that's always kind of what you're looking at to diagnose. Like the other thing you can do is compare it. So compare the performance on the training data to the performance on the test data. And if those two things are wildly different, right? If it's great at the training data and it's terrible at the test data, then you can a lot of times you can tell that it's memorizing the training data, it's overfitting,
Hmm.
so it doesn't generalize. So depending on whether it's over or underfitting, we do different things to kind of compensate for that.
Interesting. Yeah. A lot of verification. Cool.
Mhm.
I'd love to see how
Yeah,
that actually
it's a really
works. Yeah.
important part of what we call ML ops as well, which I
Okay.
think is such a good category for like cyber folks to kind of dip their toe into because a lot of data scientists don't know how to do it,
Yeah.
and they need help setting it up. And a big part of ML ops is monitoring that model in production
Hmm.
to see if it's continuing to perform well and and detecting what's called drift, right? So is the model drifting from its intended purpose, or is the concept that the model is detecting, is that changing? And so evaluating and monitoring these things is all kind of part of this like ML operations, basically like you create like a dashboard and kind of like a feedback loop that would either kick off a new training process or do something, right? If it detects that.
Very, very interesting. Learning a lot right here. I hope everyone else in the audience too. You guys are unpacking this because that's really cool. I would love to see a lot more of like that MLOps kind of life cycle and who's involved, and that would be really interesting to see that glimpse because I think that's a lot of the magic that gets hidden from us. Like
Oh
it's
my gosh, yeah.
translated and abstracted, right? Like you just see like a chat GPT model and it's like, oh, this is cool. Like it's doing stuff. But what's happening to get it to do all that stuff? That was some really good insight. So
Yeah.
nice. Thank you.
That and especially things that are like think about Netflix, think about Amazon, like these recommendation engines.
Hmm.
There must be the most incredible MLOps architecture going on there, um, in order to like monitor what's going on, update that model, make sure it's performing where it should. So like especially when things are because like anyone can build something in a Jupyter notebook, which is like what we do in our classes usually, and that's where most data scientists live, because you're just making that model and you're making it good. But like putting it into production is a super different game altogether. And honestly, a lot of times with the person I reach for first with ML ops is a cloud engineer,
Hmm.
and like somebody who understands like how everything needs to fit together. They can handle the containerization and the how, this server talks to that server and whether we need an API. Like there's just so much that happens in order to actually put a model into prod.
Very cool. Gonna talk more about that cloud engineering piece as well too. We have a lot of students that come by that are interested. They kind of get started in cybersecurity, but they want to move into cloud security or cloud engineering at some point. So that'd be cool to touch base on. Um, I want to follow up on that second part of the question, though. I think you sort of answered it anyway. Like, I guess it was put forward that is it something similar to how the human brain works with different sections? I mean, is that a fair assessment to say? Like, you put the algorithms together to almost work like a human brain, kind of create, is that what a neural net would sort of look like?
James, you are speaking to my soul. So yes and no. So it kind of depends
Yeah.
on the algorithm, but let's go back to computer vision just because that's the one that, like, as neuroscientists, we understand the best, in terms of kind of like how the brain is processing, how the human brain is processing the input. So something that, so the place where neural nets even comes from, and they're not new, right? Like these things have been around since before we really had decent computers, right? Because it was a theory in the like the 50s, and people had it on paper, like, oh, we think that the brain, we know this much about the brain. We think we could simulate it using XYZ, and here's like a picture, right? But we didn't have the compute power to do that. Fast forward, we have it now, right? And so then as we were able to get more compute power and kind of understand more, there's a whole wing of neuroscience called computational neuroscience where that's all we do. That's what I was trained in grad school, which it's funny, like someone asked me yesterday, did you ever imagine you'd be doing what you're doing? The answer is definitely no. No one cared about computational neuro back then, and it's weird that it's a thing now, but it's cool. So anyway, so one of the things we try to do is we collect data from these like visual experiments, and then we try to simulate that with what we think is happening mathematically, essentially in the computer,
Mm-hmm.
and then we compare it, right? We say like, okay, have we captured in a mathematical way something that is inherent about the biological system here? And obviously, the brain is one of the most complex biological systems that you can have. So there's just so much we don't know, we don't understand. And even when we build a model, a lot of the times we're like, well, we don't know exactly why it's the same or exactly why it works, but it does. However, with some of these models, and I do talk about this in applied data science to some degree, so early experiments about the visual system when we were first learning were with cats, and that's a little bit sad, but we learned a lot of cool stuff from the cats, and that is that basically different neurons in your visual cortex, that's back here, it's your occipital lobe, are responsible for even down to like, and it depends on the level because you have like different levels of the neuron, but at this kind of basic input level, different neurons will fire based on the orientation. So like if I show you a white screen with like a black line and it's diagonal, and then another one is like horizontal, different neurons will fire depending on the orientation of that line that you're looking at. And so we learned, oh, okay, there's something at this like most basic input level where, neurons are firing based on that. So you have parts of your brain that are encoding or responding to that. So one of the first experiments, or not first, but an older experiment with the cat was they took a kitten, and you raise it in an environment, like you put it in a box that only has vertical lines. And then you test it to see if those same neurons that we know fire for horizontal lines will fire. And they don't.
Hmm.
Because even though the brain does this, there's a lot of like setup that has to happen when you're born, that it has to learn, and it learns based on the environment that it's in. And so if you do the opposite, the same is true. So if you raise the cat in a horizontal only situation, and then you show it vertical lines, its brain basically doesn't respond to the vertical lines because those neurons, instead of being used for like, I'm going to detect vertical stuff, are doing something else. So all that is to say, the human brain is very plastic.
Mhm.
Um, but we did learn that there are certain things like that, right? So down to the neuronal level, we know that it is responding to certain things. Now, at a larger level, we know that I just said there's a visual cortex, there's an occipital lobe, there's an auditory cortex, we do have some place knowledge about what's happening in the brain, but I would encourage you to uh, think a little bit more nuanced about the brain because at the end of the day, like I used to study music, and that one is a crazy one because you're using auditory cortex, but you're also using like this specialized speech areas and all the time, and then motor, of course. And it was interesting because all the time we would find that like there are so many redundancies. We call them redundancies in the brain. So, for example, for music, a lot of times if you have a stroke in the auditory area and you cannot produce speech, uh, you will still be able to sing words. So that we call that a redundancy, meaning there's something outside of what your brain actually requires
Mhm.
to produce or do something that's there, and that's just, it could be just a byproduct, it could be, we don't know why it happens, but it happens. And so in terms of like stroke rehab, we try to exploit that.
Hmm.
Let's talk about neural networks. Sorry. So that is to say that when we interrogate some of these algorithms, like the computer vision algorithm, what they were able to find is that it is kind of, some of those levels are similar to what we see with like that cat experiment, where some of them are actually responding to like the direction of a line,
Mhm.
or it's maybe it's a little bit higher level, and so it's a little bit fuzzier. And so yes, we think that neural nets are working similarly to the brain simply because they behave that way, but at the end of the day, these things are really hard to do like a one to one, and
Mhm.
to be like, this is a whole brain, and here we have a temporal area and the occipital, just because the brain is still so much more complex than anything we can do on the computer, that we don't have like a perfect version of a human brain, but we
Mhm.
have various, let's just say, senses kind of, where we know a little bit about what's happening under the hood. Sorry, that's a super long answer, but I feel like it's a worthy story.
I think that was a really worthy story. I'm sure the audience, especially James over there, is really soaking that in. So, okay, wait. First of all, poor cat. It's unfortunate,
I know.
but interesting results that we were able to yield from that, because that makes me think, right? If we were to apply that to a model, or I guess a neural net, is it safe to say then, if I were to, because I'm thinking from like a red teaming pen testing background here, if I were to
Mhm.
interact with a model or a chatbot or something, right, and send it data that it was never trained to see, could I bypass it the same way that the cat couldn't recognize different lines based on the way that it was trained upon? Does that relate in some way?
Yeah, and the answer to that is probably not, right? And that is where
Hmm.
models are going to struggle because, well, I guess our brains do too. Because if you've
Yeah.
never ever seen that horizontal line, then even your brain maybe doesn't know how to process it.
Yeah.
Although I would argue that, especially a human brain, like I think you'd be okay eventually. This was just a preliminary,
Hmm.
this is just an experiment, right? That's basically saying like, oh, if you do 6 weeks in a box or whatever, environment rather,
Yeah.
that has this, and then I'm sure once you put the cat back, so this is a difference too. If the cat's young, like once you put it back into a normal environment, the brain is plastic, meaning it's going to change. So
Hmm.
the brain is going to be able to learn that stuff, especially if it's younger. And so we know for a fact, right, the brain is less plastic as we age. So this is why, I'll give you another example. I used to study cochlear implant patients, and like when we give kids cochlear implants, so cochlear implant is just it's basically like a wire that we put into your cochlea that's going to fry all of your usually broken, things that are, giving you, basically taking the signal from like the world to your brain, the
Hmm.
sound signal, and replacing it with like a wire that's going to respond to that stuff.
Hmm.
It's not, it's a very nonlinear process. So it doesn't work just like a human because we don't actually fully understand how the cochlea is transducing that information. We
Hmm.
understand aspects of it, and it works fairly well. It does allow people who are, especially if you're profoundly deaf, you will be able to hear. But when we give people cochlear implants that are young, especially like infants, children, they adapt beautifully and they integrate just fine and they love them. They don't really have any issues. Um, is it perfect just like you're in my hearing? No, but like they can hear the world, they understand speech. When we give that to adults, they, I mean, a lot of times they hate it. And I've seen more than one adult actually just turn it off and be like, this, I cannot understand. I don't know what is happening. This doesn't sound like hearing to me.
Hmm.
And that's because it could partially be because, you know, maybe this patient used to be able to hear and they've lost their hearing and it's just so different that their brain is like, no, thank you. Because it is different. It sounds very mechanical, its pitch is difficult. But what happens is also, we think, is that as you get older, your brain is not able to adapt to this new kind of hearing. And so you know, I think that neural nets are the same way. If we have a bunch of stuff that it's never seen, so this is why we train them specifically for various things, right? Like you have a neural net that's good at detecting fraud. You can't just have it do some other task
Hmm. Hmm.
necessarily. Now, language models are special because, like, if you look at the Chat GPT of the world, these you know, general LLMs,
Hmm.
they are becoming quite good at switching and interacting with modalities. I think that when they do that, they're usually kind of expanding the training data, expanding the architecture, changing it so that
Hmm.
it can do these what we call multimodal, you know, inputs. So it can take in a picture, it can put text to something else. You still have to train it on like adding text to a picture,
Yeah.
right? So to say that there's a neural net that would be able to do basically all the things we can do, like we're nowhere near that. We still
Hmm.
have to show it something of what we want. Otherwise, like it's not going to know what to do.
Fair enough. That's a good breakdown of it. Um, because tying this back actually with our chat yesterday, with everyone hanging out at the Facking Friday event, we did have a small discussion just on that, from like a web application security perspective, because as these tools get better, as scanners increase, and something that I was throwing out was, and tell me how far off the mark I am because I'm no specialist, something I'm still kind of thinking about learning, but I had this proposition, I guess, that if you were to get several different types of chatbots or models, whatever you want to call them, and maybe you have like a marketing trained model, a sales trained model, a CEO trained model, right? Like you get these individual models that can all do something really well, but then you have a general oversight model that can see what they're saying back and forth to one another to pick up on the anomalies. Could it then train itself on those anomalies and effectively learn at that point?
Mm-hmm.
Is that even possible or?
Yeah, so theoretically, absolutely, right? Like that,
Yeah.
that's exactly right. Way to go. So
Thanks.
yeah, that's kind of the idea, right? Is that you have this like kind of supervisor, and this is sometimes it's called like semi-supervised learning, because like the model is kind of supervising itself in a way, or you
Hmm.
have another model supervising these models. But the and part of the reason that like the language models are so good is because they're being trained on so many things, right? You're not unlike a what I'll call a traditional ML model.
Hmm.
You're not just trained like if I were to make a fraud detection thing, I would be like training it on that, right? But if I'm able to take one of these huge large language models, I could probably say detect some detect some anomalies in this, and it may be able to do it. And that's because it has seen so much stuff. It has just seen, like, you know, think the entirety of the internet, right? Like it has seen so much that
Hmm.
it's able to. take what I said and become and do some very specialized things like detecting fraud. So you can do it the way that you said, which I think is probably a safer, more ethical way to do it. Um, and or
Uh,
you could take one of
yeah.
these really, really large models. And the other thing you have to think about with these two scenarios, right, is that like LLMs are really good, especially these generative models. But they're not like free. Like they're kind of
Hmm.
actually, if you can use an API, they're great because that's like a super cheap way to do it. But a lot of people can't like hit the internet, so you have to be doing it somehow locally or paying for it yourself, and they're they're kind of expensive to run. So
Yeah.
a lot of times we do still use methods like you're talking about, Anthony, where you have like kind of this like supervisor model that's tracking other things, and it's more economical, and you could kind of tailor it to your use case a little bit better.
Hmm. Interesting. So there is some type of, I guess my approach seems rudimentary based on your answer, but sounds like it's part of
Oh,
the process at some point. Yeah. Hmm.
no. I wouldn't think that's not rudimentary at all. In fact, a lot
No.
of people have no idea how to build something like that. Like that's
Interesting.
a pretty specialized type of learning, type of putting together an algorithm.
Cool. Very cool. Yeah. So to sort of expand on that, the discussion that we are having was around having like a web application scanner, right? Like if we are a pen tester and we're hitting a web
Mhm.
app and we're looking for the various endpoints, the different APIs, anything we can hit. Maybe,
Mhm.
let's just use the URL for example, right? Like different ways that we can hit like login.php, whatever, change password, like all those endpoints that we could hit. And then you're looking at the HTTP request. So you have the
Mhm.
headers, you have the data, you have response codes, you have all that, all those things around HTTP, right? The
Mhm.
us as humans right now, we're still better than saying run a vulnerability scanner like like Nessus or Acunetics or one of these scanners, right? Because they do a thing and then it comes back and it's quite generalized still, and then we as humans come in and we kind of poke around. So the there was some conversation kind of going back and forth in this is what would it take to replicate some or all of what that human can do. Like, what's your take on that? Is it possible? How far off are we on it? What would it, I guess, theoretically require to get that human level of probing and poking around and doing things that a scanner wouldn't do?
And I don't know, like good luck, honestly, because what especially pen testers are doing is so broad. Like, because
Yeah,
think about the you're not just like analyzing some data, right? Which is
yeah,
what we really do at the end of the day with data science. You're you're dealing with everything, right? You're poking this, you're testing that, you're looking at logs. Like, if you think about like the number of tasks that are involved with what you're
mm-hmm.
saying,
Mm-hmm.
I'm skeptical, right? That like, yes, scans are good. I mean, don't get me wrong, I'm not like dissing scans. I use them every day,
Yeah,
but at the end of the day, yeah, you're not going to be able to beat a person coming in because a person is still hacking, right?
mm-hmm.
So I guess it probably will evolve at the speed of the hacker. So if we find a model, or if we were able to come up with a model that could handle all of those things, which it's possible.
Mm-hmm.
I don't know how likely it is or how quickly it's something that could be developed, especially
Mm-hmm.
with a lot of the cybersecurity we have in place typically. It's going to get throttled at permissions, right? And it's
Yeah,
not necessarily going to know how to get around that stuff. Could we develop one that could effectively hack? Probably. I don't think we have it today.
yeah,
But as those models at hacking get better, the models at pen testing are very similar because like as you know, like the skills for hacking and detecting are very similar. Like you kind of
mm-hmm.
have to be able to understand what's happening there. So I think that that's what it would take, if that makes sense.
Mm-hmm.
But I don't see that happening because even if I were to try and like throw a model at a problem, like it's going to get tripped up so much on even just probably the simplest like permission stuff. So
Yeah.
it's hard for me to imagine a model being able to do all those tasks. And are we going to need general intelligence models to do it? Maybe.
Mm-hmm.
Um, and I think we're pretty far off from those, to be honest. Um, but maybe we would be able to do it sooner than that. It's a terrible answer. Basically, I'm kind of saying like I don't think we have it now. I don't think we're going to have it anytime soon. So keep your jobs.
Yeah, exactly, right. I mean, that's good. It's good for the audience to hear that too, whether you're a listener here or listening to the recording afterwards. It's definitely that type of question is quite common. I mean, if you go hop on NetSec, cybersecurity, InfoSec, Reddit, even if you go hop on like graphic design, right? Like if you look on all the Reddits right now, 3D modeling, everyone's like, oh my god, should I start this because AI is going to take my job, and they're going to be able to replace me. So, and that's kind of why I wouldn't say that's why we were talking about it yesterday, but rather just from like an ability to be more efficient was more the conversation topic yesterday.
Yeah, you want to be able to use the AI, right? Like
Yeah.
I don't calculate things by hand because it's pure or whatever. You know what I mean? Like I
Hmm.
use calculator, I use a computer, I use whatever is available to me to make my job easier because I'm lazy. But oftentimes you're gonna want to use that AI when you can.
Hmm.
Like I said, especially as cybersecurity folks, like you're gonna be in a lot of situations where you can't just like throw things into an LLM or you don't have that at your disposal.
Yeah.
Um, and that's not going away. There are still so many like air gap systems and people and companies who just can't use LLMs and countries that are going to start regulating this stuff. I don't think the US is going to be one, but I think that, other countries certainly are and will. So, it's good to know what they are, be able to use them to your advantage. But, there are certain skills, I think, that are going to be less useful and industries that are going to change. But I don't buy this stuff about like, well, we don't need software engineers anymore. We don't need this. We don't need
Hmm.
that. Slow down. Yes, we do, because at the end of the day, no one is taking what comes out of Chat GPT and being like, well, this is good. Go ahead and put it into production. Like, absolutely not. I The same way you wouldn't do that if it wrote you a paper, right? Like
Yeah.
it's not good at facts. It's just putting together and using statistics crap that it's already seen before.
Yeah.
So here's the other problem we're going to run into pretty quickly is that unless these models continue to be trained on new human generated things, which is going to get harder and harder, it's like eating its own tail at some point. I was just talking about this last week on a panel where I was saying like all the content that's getting generated that it can train on, like the publicly available stuff on the internet, is generated by an LLM, and
Yeah.
and we're using that to keep it up to date.
Yeah.
It's going to be like a diminishing return at some point because it's like not seeing anything new.
Hmm.
It's seeing old stuff that it's already generated,
Hmm.
and like it's not actually learning anything new. And it's so I wonder, 5 years in the future, if it's just going to stagnate or if something's going to happen and
Yeah.
we're going to need some kind of paradigm shift to get over that.
That's a fair, yeah. Like I like that you're saying that because that hits home quite interestingly to me. Right? Is it seems like AI is developing at such a rapid pace, but is that just because it's rapidly learning all the existing material and it appears like it's much more useful? However, yes, once it runs out of training model data, what happens then? Like it's going to
Right?
really slow down, right? That threshold changes. It's not new anymore. Um, that's interesting. I like that you're saying that because that helped me clarify something as well. And I hope the audience as well. That's a good way to think about it. Um,
Yeah. And at the end of the day, somebody has to check that output. Like
yeah.
if so people are always like, "Oh, well, I could just generate it with this." I'm like, "Yeah, but who's checking that? Like, who's debugging that, right?" Like,
Yeah.
think of it as like a novice junior person on your team. They're going to generate some code, but like somebody needs to check that and oversee it and make sure that it's like doing what it's supposed to be doing and that it's not just like putting random stuff in there. Like if you ask it for a recipe, it'll be like, "Oh, you should use glue," because somebody did like some satire one time about using glue
Hmm.
and now it's repeating that. So there's like parts of the training data it has memorized
Hmm.
which could be useful. And
Yeah.
like sure, maybe it's which is why I say like you should know how to use it. Use it to make a template, right? Like use it
Yeah.
to make so that you don't have to make stuff from scratch. But then like and then it's like for me I'm always like, what's faster? For me to debug this crap or for me to just write it from one of my previous things that I know works.
Yeah.
And, for me, the latter is like faster.
Yeah.
But if I'm learning,
Hmm.
maybe not. Maybe I'm going to use that template. But at the end of the day, you still need to be able to, you need to know enough to debug this stuff, or somebody does.
Yeah.
Otherwise, like it's not going to be useful. So
Yeah.
there's
Yeah. Yeah.
still there's still jobs for us. Don't worry.
Good stuff. Good stuff. Hope you're all enjoying that commentary. Everyone listening, still got work to do. You're not getting off easy yet. Um, cool. Well, we got a couple more questions as well too popping up. We have Jess over here asking, what traits do you think a good data scientist needs?
Traits. So it's really cliche, but like curiosity um, is an important one. And I guess what I mean by that is that you want to know your it's interesting to you to find out why something is happening, or
Hmm.
to dig into something and to have the ability to like stick with a problem. So I find that a lot of a lot of data scientists kind of make the mistake of they like data science because they want to use the latest greatest toys.
Hmm.
There's nothing wrong with that, but if you approach every data science problem from that, you're gonna have a bad time, because uh, really you wanna take it apart piece by piece, like a puzzle, and you don't necessarily want to just start with sometimes what you need is a knife or a scalpel. And if you put a machine gun at everything, then a lot of times you're just hitting your head against the wall. And you're like, why doesn't this model work? This model doesn't work. And I see guys do this all the time. They've been, just throwing things at this model for like 6 months. And I'm like, well, you need to step back, right? And look at
Hmm.
like, what are the features that you're putting in there? What are the things? And so the kind of desire to do that, and the interest, right? Having that be interesting for you is going to help you a lot. And I say interesting just because I don't necessarily think it's a trait. I just think it's kind of about, you know, what do you think is cool? Because if you don't, it's not that you can't do data science, but you're not going to enjoy it as much.
Hmm.
And so I think that kind of like curiosity, ability to kind of take things apart and to really dig deep. So it's, I guess another trait would be like being able to sit in front of a computer for a lot of hours at a time is helpful.
Superpower.
I think
Yeah.
right. I feel like that's my superpower for sure. Is like my ability, and that's not to say like I'm always focused. Like we all get distracted. We all have days when like we can't focus, right?
Yeah.
But having the ability to, on some kind of schedule, be able to just sit and like dig into something for a long time and uh, focus on it is important. And I know that not everyone can do that, and not everyone's like personality leads them to that. Although if you're in this chat right now, you're probably in that camp. So I'm preaching to the choir on that one. Another one is the ability to gather the knowledge that you need to do what you need to do. So even like I've been doing this for over 20 years. I know a lot of algorithms, but I rarely come onto a problem where I'm like, oh yeah, I know exactly what I'm going to do. I'm going to do this. Even if I feel that way, I'm going to go, I'm going to hit Stack Overflow. I'm going to hit up Archive. Archive is like a big repository of computer science papers it's all free. It's freaking great. Yay, computer science for like, you know, always being pretty much that way.
Hmm.
Biology is like super gatekeepy, and you have to pay for everything. But when it comes to algorithms and computer science, there's a ton of papers out there you can read. And I'm going to read blogs. I'm going to read what people are doing, and the ability to kind of go and gather that information and distill it, and to like read a textbook and be like, okay, how does this algorithm work? Um, is this going to make sense for my data? Those things are really useful and important. Um, Another trait is the ability to communicate complex things in a simple way. And that isn't something that has, you don't have to have that today. That can, all these things you can improve on, I feel like. But if you have a little bit of natural ability, it does take you a long way because at the end of the day, the people paying for this stuff, they're not data scientists. It's very, very rare, right? They're going to be the C-suite or your manager or your client or whatever. And just like cybersecurity, you kind of have to justify your existence all the time. And so, not in a bad way, but just in like a way where you're like, hey, I want to use a GPU. It's going to cost a bunch of money. Here's why it's a good idea, right? And you have to be able to explain that in a way that doesn't take a PhD level of knowledge on their part. Um, Collaboration is good. Humility will always get you farther than anything for my money. Um, and it's that's a tricky one because especially when you're a consultant, like they want you to come in and they're expecting you to be an expert. And
Hmm.
so I know when I was younger that always scared me because I was like, oh gosh, if I act like I don't know everything, then they're going to be like, oh, you're not an expert or I'm
Yeah.
paying you too much. But that's not I don't know. It's not true. I mean,
Hmm.
if you clearly don't know anything, then yeah, they're gonna pick that up. But you have to balance your imposter syndrome with like their their desire to have an expert. And so, you know, especially when you're not in front of the clients or people that are expecting that from you, humility is really important. And that in real life, not just acting humble and like being able to collaborate with people, but like knowing that you don't know everything and understanding that and being like other people about it as much as you're allowed to is great because and that's what makes good science, right? So it's not called data engineering, it's data science.
Hmm.
Because engineering is like I give you a task, you do the task, it's a thing, it's kind of a factory kind of a thing. There's like some experimentation involved. But science, and I think this is why we call it data science, is a little bit of a different animal. Sometimes your experiments are going to fail. In fact, a lot of times they're going to fail and like
Hmm.
that's okay and that's part of the process and that's built into it. And so being able to kind of like be humble enough where when those failures happen like you can explain it and be like, well, this happens and I don't know everything and not every problem is meant for a model. That's also something that happens. So understanding that we are better scientists because we stand on the shoulders of giants, right? So
Hmm.
the more I can collaborate with my peers, yeah, maybe this person doesn't have as much experience as me, but like they think about it differently. They know different stuff than I do. And so, getting input from I guess I'm back to like gathering the info, right? Like getting input
Yeah.
from multiple people, multiple places is extremely important.
Solid. Really good. So what I took note over here was curiosity, resourcefulness, being able to sit on a chair for great lengths of time, know, knowing your audience, being collaborative, and humidity. Not humidity, humility. So does that sound kind of right? Like that's a little
Yeah,
summary there of the traits. Yeah, nice. Very
good
cool.
distillation of my ramble. I love it. We're a good team.
Thanks. Yeah, that's right. Awesome. So I hope that answers the question over there in chat as well. And I like how, you didn't even really mention like go get a computer science degree, go be super technical, go
Because it's a
and
degree, I was trying to stick with traits. I was trying to
yeah,
not do
yeah,
skills.
yeah. And I like that. Like it's a good delineation, right? Like these traits are. I think a lot of people have these traits. And
Yep.
maybe you just need a better chair as one of them. Then you can sit longer. But the rest, you should be able to. I think
Yeah.
people have these, but they kind of shut them off. They just want to get into a groove, and life kind of does that as well, right? Like the normal jobs that we do sort of doesn't encourage these traits to develop. But I think if you
Yeah.
open it up, um, everyone can become a data scientist. That's my
I
my
totally agree.
positive
Like
statement there.
no, I totally agree. And yes, there are skills you're gonna have to acquire
Sure.
along the way. We could switch
Yes.
over to that. There are skills you're gonna need. There are degrees that are helpful, right? There are courses that are helpful. I am like a course. Maybe this is because I like teaching or why I like teaching. So I just like taking classes. I like learning.
Hmm.
Um, I I don't know. I take classes all the time. Like it's crazy. And it's funny because sometimes people do get weird about it. They're like, "You're supposed to be an expert." I'm like, "Yeah, I don't know everything. Like I want to learn this thing. I'm gonna go learn it. Like don't give me a hard time." Um, so it's funny because after you get to a certain point, like you're in your middle age and you're like a senior person, it is tricky because then people are like, "Why are you doing this intro course?" And it's like, whatever, it's a whole thing.
Hmm.
Don't worry about that yet. You're not there yet. But that's a good thing because then you can just tell them to fuck off.
Yeah.
So so a computer science degree can be really helpful.
Yeah.
Those courses can be really helpful, but finding what works for you is really important. I know a lot of people were self-taught, and
Hmm.
a lot of people are happy with that and do really well with self-teaching and like textbooks or self-paced class coursework. Um, and some people really need like one-on-one instruction or classroom instruction, and the more modalities, so we'll do some brain stuff here. The more modalities you can learn something in, the better you'll learn it. Especially if you're memorizing, which nowadays I feel like we do a lot less memorizing than we used to.
Hmm.
But because so you'll see people say like, "I'm a visual learner, I'm an auditory learner, whatever." This is kind of a myth. I do think it's true that we have preferences, right? Like I actually love auditory as a medium. Like for some
Hmm.
reason, it's stickier for me than like vision, but it doesn't mean I can't learn visually, right? And at the end of the day, to get something to stick in your brain, you want to. So there's two things that I really like. One I've recently learned, and this is like a med school thing, which is I think it's like watch one, do one, teach one. Uh,
Hmm.
and so, because like teaching is kind of the ultimate of do you really understand something?
Hmm.
And so that's like built into the way that like med students train
Hmm.
is they like teach each other or whatever. Um, and I think that's really smart because even if you don't have an audience, trying to prepare something as though you're teaching it is really a good test and can sort of force you to dig into something the way you wouldn't normally. Do you need to know everything that well? Probably not. Um, and the other one is like I try to hit as many modalities as I can, right? So if I can see it, I can hear it, I can do it. Especially with data science, that's easy because you're at the keyboard, and then kind of teaching or communicating, we'll say that
Hmm.
is kind of that extra modality, which is more ways you can kind of slice something, the better it's going to stick in your brain.
I like that. Yeah. Something we advocate a lot with our training too is not the same way you said it, but learn, do, teach model. That's what we really push.
Yes,
Yeah, that is, so we're saying the same thing. I haven't heard that the med school version, but I like both. I think that yeah, they say the same thing different ways. Awesome. Really, really good breakdown. I'm glad that you spent some time to expand on that. I know we have another question coming up over here, but I think that was a lot of important coverage to get people thinking into a different perspective and understanding some of the realities. You will fail, and I like the that comparison and contrast of science and engineering and why data science is what it is to hypothesize, challenge yourself, challenge assumptions, which is a bit of a different task, right? Like engineering, you said like you're just like here's your problem, go solve it with best practices kind of thing.
Mhm.
But the science component comes in and says, well, best practices are good, but what are all the other ways we can do it now? So
Exactly.
that sounds more fun to me personally, and I hope everyone else as well too listening. You guys might enjoy that as well. So cool. Um, let's hop over to this other question because I know we've been talking a lot. There's a lot of good stuff. I always feel like I learn a million things talking to you, Summer. So let's get back and try with we got another question over here, kind of two questions, and we'll see how much longer we do talk for this episode. But the question over here is GANs, so General Adversarial Network. I would say I think that's
Hmm.
what that is,
Yeah.
right? Seem to
Good
be
job.
very things seem to be very powerful for finding unique solutions to problems, or at least finding unique problems. So, do you think this is a
Uh-huh.
good approach to getting insights into potentially unforeseen problems, or is this too much of a black box for the reasoning to be intuitive? It's a deep question.
Uh, I think it could.
Hmm.
So GANs are something that I actually don't use a ton of GANs in my work, but I know they're very popular with like um, security and kind of like finding, like you were saying, like kind of looking at that threat space and kind of finding new unique problems or finding solutions to those problems. But finding unique problems, it's tricky, right? I think gotta just like everything else we've been talking about, you got to narrow it down for the model, and depending on kind of what that latent space looks like, that that it's looking at, it's trying to capture or find something in, I think it's possible. I don't think it's too much of a black box for this reasoning to make sense. um, and yeah, I mean, I don't really have a lot to say about GANs just because it's not like one of the things that I'm super duper, I don't have a lot of expertise there, so I'm not gonna like pretend that I do.
Yeah, fair enough. Um, and I think part of the question as well too is maybe also saying, and correct me if I'm wrong, but is it giving us more work, or is it creating work, or is it just like busy work appearing as something useful by using something generalized, like a generalized
Mm.
model over here? Um, I'm not sure
Yeah,
if
and
I'm
I think
maybe. Yeah.
this is where the science comes in,
Yeah.
because this is like a perfect data science question, right? It was just like, would this work?
Hmm.
Uh, not like, oh, this is a problem, I'm going to build a model, I'm going to solve it, which is also still data science. This is even more fundamentally science, because we're saying now you have like a hypothesis, right? And you're
Hmm.
like, is this is this problem something I could approach with a GAN, or would a GAN even work here? And so the more kind of narrow and specific you can make your problem, or the data that you're looking at, then the better off you'll be. But this is certainly like a good one to sort of test and try, and that's what we do. And hopefully you work somewhere that also understands that, and I think that's always a not always, but it can be a push and pull, where sometimes you have to educate people on what data science is, right? You're not just a data analyst, which is fine. And if they want that, you should give them that.
Hmm.
But data science is different, right? It's stuff like, hey, this might work. It also might fail. So, like, is it cool if I check this out? Kind of a thing.
Hmm.
But this is a good one for that, for sure.
Interesting. So, what would you say then? Because you're mentioning a data analyst over there with this type of problem.
Yeah.
Yeah. I mean, how would how would they support the data scientist? And is it fair to say is that like the linear growth? Like, do you study data science? Do you become a data analyst, and then do you become a data scientist, or are they just different traits and skills and supporting needs?
Yeah, this is like a classic question. I remember when I first got into data science, I also was like, what the hell? Like, why are there so many
Yeah.
things? Um, and so I'm gonna give you my take, but that's all
Hmm.
it is. Because every company is a little bit different, and there's no real definitions for this stuff yet. I think someday there probably will be, but the what I see now, actually, I'll just tell you what I hire for. What I tend to hire for, and I see this in other places too. It's not just me.
Hmm.
When I'm hiring for a data, I'll talk about the skills I like to see. So, data engineer is a title. A data engineer is somebody that is really good at like rocking the data, understanding creating features for me if I'm doing the science part, making a pipeline, a sustainable pipeline for bringing that data in. Maybe you're making an API to pull the data in. Maybe you're hitting an API.
Hmm.
Just anything that involves like gathering, storing, and preparing that data for a model is kind of a data engineer's job. And depending on my stack, maybe I'm on prem and you don't really need much cloud. But more often than not, I'm going to be doing things in the cloud. So you're going to need to know, maybe the AWS suite of tools, and I want you to have some experience there, or Azure, or some sort of, it translates fairly well. So as long as you have like one cloud data engineering stack kind of under your belt, and you're aware of the tools, you know how they work together, that's usually what I want to see there. And that is more of a you're going to need to understand enough about modeling to know what has to happen to the features to get them into the model, right? So you don't need to know every model, every algorithm. You don't even need to be great at math for that one, right? But you need to be able to like scale the data, normalize the data, and create all those pipelines and uh, detect the missing values, be able to just like handle all of those kind of uh, just cleaning essentially.
Hmm.
Um, then we have data science, right, which we've talked about. It's where you don't necessarily know what model you want to use, but you can look at the data, look at the features, and know which models you want to test, and then be able to test those models and say this is the best model. Then you have data analysts. So if I'm looking at a data analyst, I'm looking for somebody who uh, maybe isn't necessarily like an algorithm expert, or even like a math expert, but somebody who is great at taking a business question, like, and knowing how to get that data into a state where the business people can consume that.
Hmm.
So this might involve some data, depending on how
Oh,
big the project is. Um,
lost you there for like a quick second, but I think
did
you're
you?
good now.
Okay.
Yeah.
Hold on, it's because my phone is ringing.
Broke up the reception. Yeah, all good, all good.
Okay. So it also depends on how big the project is. Like if you're
Yeah.
on a small project, congrats, you're doing all of it. But if you're on a bigger project that's got more money to spend and maybe just has a ton of data, then you'll get into these some niche things. So a lot of businesses and people think they need a data scientist, but what they actually only need at the beginning might actually just be a data analyst, right? They've
Hmm.
got data, they want to consume it, they want it in a dashboard, and I would hire a data analyst to do that. So you need to have some stats, you need to be able to do some analyses, create time series, and do the visualization piece really well.
Hmm.
But you don't necessarily have to be doing modeling. But a lot of times you'll see these people overlap skill sets all the time.
Yeah.
So I wouldn't say that like, oh, data scientists never do modeling. There's no never in any of this. This is just kind of my take on it. Um, then you have your ML ops, which we talked about a little bit. And the ML ops piece of it is where, I build a model and now it needs to go into production. So you're going to take my Jupyter notebook.
Hmm.
Maybe I'm going to actually do better and actually put it into Python and make it nice. But then you're going to take that model and that pipeline that my data engineers created, and you're probably going to work with the data engineer to create an architecture, right? So this nowadays, this is being called solution architect,
Hmm.
um, and it's called like we just started a new job title at my company called an AI solution architect, and that's what I would expect from that person is to be able to like what permissions are do you need for the model server to talk to the retraining pipeline versus the data engineering pipeline, which needs to talk to the database.
Hmm.
And like, what does the feedback look like where maybe you're collecting feedback from users or you have a bunch of testers and you're doing an reinforcement learning human feedback design. How does that work and where does that go? So kind of setting up the literal architecture for all of that to work together is what I would see in that kind of solution architect role. So those are kind of the different, I don't
Yeah.
know, I would call them data science roles. You'll also see machine learning engineer. Sorry,
Hmm.
one more.
Yeah.
Um, so machine learning engineer, at the end of the day, it's just a different name for data scientist, in my opinion. It's
Hmm.
sometimes it's somebody that's a little bit less on the exploratory side, and it's more on the side of like we already have a model, we like the model, but you need to tune it and make it good and like explore it and like harden it and get it ready, tune the hyperparameters, all of that.
Hmm.
But more often than not, ML engineers are, a different name for data scientists.
Yeah. No, that's really good. I think the only thing I was going to say there is that again, just like as we last spoke, there's so much overlap there with what I hear with cybersecurity as well. Like a
Yeah.
cybersecurity analyst working with just, it's not business data per se, right? It's like the user network endpoint telemetry. Like there's a lot of data, and you're just an analyst for that data, and you are then consuming it and responding it and working with it to provide some type of result, which is typically triage or preventing an incident from happening. But then you have the
Hmm.
engineer, which again was working with the tools, the database, the APIs, kind of tying things together and providing an overall solution. And I guess to some degree, right? Right, we have the cybersecurity researchers as well that are a little bit more academic, looking to encryption, different ways that we
Hmm.
could do something. That's where the science kind of comes in. So I love it because whenever you start talking so much about data science, I see so much overlap with cybersecurity. There's a
I'm pretty sure
ton.
we took it all from cyber. I'm pretty sure. Like
Yeah,
we talked about this on the pod. Like I
yeah,
think that a lot of this is born out of cybersecurity. I think
yeah,
that that was our OG use case,
yeah.
and it's like academia and cybersecurity had a baby, and it's data science.
I like that.
You know,
That is really good. Got to get
and you
that on
know
a
what? You know
slogan
what's going to
somewhere.
be a new job? It's not a. I don't think it's a job yet, but it's definitely going to be one, which is AI security or model security. Right?
Yeah,
That's a thing,
that's a
and
thing.
that's a thing that data scientists don't know about. Like they're not trained for it. They don't know. Like one of the biggest issues we have right now is that like we save everything in Python as like a Piggle file, and you can
Hmm.
put it's like a Docker container in that you can just like put any executable in there, and when you deserialize it, it's going to execute. Like you've got like ability, you've got all these permissions, and so it's a great way to like. There aren't a lot of attacks that way yet,
Hmm.
but it's certainly a good vector for it, and it's something that I already have clients asking about. So I
Yeah,
think that as a job is totally going to be a thing, and I think it would be very organic to come out of cybersecurity. So that's coming down the pike, I think.
that's super cool. We're definitely gonna have to get something on that, a talk or demo or something towards that in the future after we sort of establish some of this baseline learning content. I'm gonna come back to you on that because that does sound really good. Um, so we're definitely over. It's a good conversation, but we have one last question over here inside the chat, and then we'll kind of leave it open after that, and then we can start wrapping up this AMA. Last question over here is: could you describe a typical day for a data scientist, including working hours and team dynamics?
Ooh, typical is hard because it really I don't work in a very normal place, just meaning I'm a consultant. So what that means is that at any given time, I'm working like three different projects. Um, so my experience is a bit weird. And I'll try to kind of tailor it more to like the times when I have worked on one project. Um, but you're going to be doing it's a very similar a day I think is a very similar to like a software engineer day. So
Mm-hmm.
you're going to usually like have a stand up. You're going to start out with some kind of a stand up with maybe it's the other data scientists on your team. Hopefully you have a few on that project. But maybe it's you and the software engineer and the cloud engineer and cyber, and you guys are just checking in. Sometimes those are daily. Sometimes those are like a couple times a week. Just depends on what the project manager likes. And then I'm going to be doing any number of tasks that pertain to the data science. So maybe I'm cleaning the data. Maybe I don't even have data yet. And now all I'm starting out with is like, I have like 5 meetings with people because I'm trying to figure out who the hell owns the data. Um, so there could be meetings, there could be cleaning usually. And then, maybe I'm testing a model. So maybe I'm checking what happened overnight on my SageMaker, endpoint and to see, the metrics and how well or terrible it did. Maybe there's a security scan in my GitHub that I got to address and figure out. Or maybe I'm just doing, and maybe I'm doing a little bit of research too, because maybe the model did really well, but I want to see if it could be better. But I want to like make sure I understand every single hyperparameter. So I'm going to go to the documentation. I'm going to look at that. So that's kind of a typical day. It's like some meetings, but a lot of like sitting in front of the computer and doing different kinds of data science tasks. And then, um, you know, occasionally you're going to be presenting that stuff. So maybe it's a little less painful every day if I'm working towards making that documentation of what I did, and maybe contributing to that like presentation because I know I'm going to have to like tell somebody at some point what I did, just because I have a job, and that's easier if I do a little bit every day. That's my kind of terrible answer for you there. Team dynamics depends on the team. I mean,
Yeah.
if you're working with data scientists, you're going to work really closely together. You're going to like talk a lot. You're going to talk every day. You should anyway. Um, but if you're the only data scientist and you're working with like software engineer and front end engineer and a cloud engineer, you may not necessarily be talking to them every day in the beginning, but maybe at the end, you're kind of working more together. So I don't know if that really answers a team dynamics question, but that's all I can think of.
So basically, an entire day built around the traits that make you a successful data scientist. That's
Yeah.
that's pretty much it, including the chair as well. Yeah, no, that's really good. Yeah, you got a big thank you there from the chat. So
Oh, good.
yeah, I that helps clarify some things. There's a lot of curiosity involved, resourcefulness, all the things you mentioned. So that's pretty cool. Um, I think I think that's the last question over there. I'll give a minute over here for the chat if they want to throw any last minute things down. Otherwise, Summer, it's always a pleasure having these conversations with you. Like I said, I learn a ton. I feel like I'm getting better with data science just by talking with you and kind of learning and training my own mental neural net model over here and probing
Perfect.
you in ways. So yeah, very
Well, it's
cool.
always a pleasure. I appreciate it.
Yeah, it's really good. I do see James actually type in, so maybe he's got one last thing to say. No, he just wanted to thank you. Okay,
Just that I am great.
that's
Thank
it.
you,
Just
James,
a
for the
little
great
love.
questions. Thank you, Jessica. Appreciate it.
Awesome. Thank you all. Um, and we'll kick this off. This will be a recording going over to our YouTube, so everyone can get a listen to that. And again, thank you all for spending your Saturday with us, taking some time out, learning about data science, and asking some really great questions. And look out for June 7th. That's the release of the first of many courses, the Applied Data Science, the ADS 101 track. If you want to get started with any of this, all you listeners, that Python for Data Science course is going to be what sets you up for success. So look out for that coming in a week's time. But thank you all again, and thank you, Summer, for being with us.
Thanks, everybody.